All right, ready for a deep dive today? We're tackling Go. Golang. It's everywhere you turn these days, and we're going to break it all down.
Yeah, and we've got the goods to do it. Official documentation, effective Go, even that Wikipedia rabbit hole. We're going deep.
Love it. No stone unturned. So, Go. Golang. Why is everyone making such a fuss?
Well, imagine it's like 2007. You're at Google. Maybe you're Robert Griesmer or Rob Pike or, Ken Thompson.
Hold on, Ken Thompson, as in Unix Ken Thompson.
The one and only. So these guys, they're facing the limits of what's out there language-wise, and boom, Go is born.
Talk about a pedigree.
Yeah.
But Google made it, yet it's open source. How does that work?
Right, so anyone can jump in, contribute, use it, change it, the whole 9 yards. It's a language by the community, for the community. That's a big part of its appeal.
Gotcha. So no corporate overlords. Now, effective Go was pretty clear. Just translating, say, your Java code directly into Go, that's not going to fly. Why is that?
It's deeper than just the words you use, you see. It's a whole new way of thinking. Effective Go calls them Go's idioms. Like, take functions, right? In Go, they can return multiple values. It's wild. And that changes how errors are handled. Everything's connected.
Multiple values. All right, now you've got my attention. How does that even work, and what makes it better for errors?
Okay, so say you've got this function, dividing 2 numbers. Lots of languages, you'd return the answer, or if it blows up, there's an exception. Not Go. Go's like, I'll give you both. The result and an error value together. So you check that error, and if it's not nil, bam, you know something's up.
Like a 2-for-1 deal, but for code? Elegant. I like it.
And effective Go, it gets into how this changes everything about how you approach errors in Go. They're just another thing to deal with, no drama.
Love that. Very practical.
Yeah.
Now, they also mentioned defer, and I got to be honest, that one sounds a bit mysterious. Break it down for me.
Defer is like setting a reminder in your code. No matter what, success, failure, whatever, this function will run right before the current one finishes up.
Like a built-in cleanup crew, making sure nothing's left behind.
Exactly. Files to close, resources to release, whatever it is, defer. Make sure it happens. And here's a fun bit. It's not tied to a block of code like in some languages. It's tied to the function. Opens up some cool possibilities.
Huh. Interesting. Go seems to be all about that power meets elegance vibe. Speaking of which, let's talk data structures. Arrays, slices, maps. The usual suspects, but I'm guessing Go has a twist.
Oh, absolutely. Take arrays, assign one to another in Go. You're not just pointing to the same thing, you're copying the whole shebang, the whole array, which effective Go points out can be good or bad memory-wise.
Yeah, most languages, you're just referencing the same data. That's a big difference. Could prevent some nasty bugs, but also memory hog, potentially.
Exactly. Trade-offs, trade-offs. And if you need that flexibility, Go's got your back with slices. Like, think dynamic arrays that grow as you need them. Super handy.
Dynamic arrays, nice. But okay, Wikipedia throws us this curveball. Apparently, Go didn't even have generics for ages. What's the story there? Ah, yes, the great generics debate. It's a whole thing in Go's history. So generics, right. Write code once, use it with tons of data types, everyone's happy. Except in early Go, they just weren't there.
Really? But developers love generics. Why leave them out?
Go's creators, they had their reasons. Keep it simple, avoid the headaches other languages have, that was the goal. Effective Go even kind of hints at this, how they were intentionally trying to be different. But man, did it spark debate. People were not shy about wanting generics in Go.
Sounds like they stuck to their guns for a while. So what changed?
Well, they eventually came around after tons of discussion, trying things out. Finally, Go 1.18, boom, generics arrive. But the whole debate, it shows you something important about Go. This isn't a language afraid to shake things up,
Yeah.
even if it means going against the grain.
A language with convictions. And speaking of potentially controversial, even Go's famous concurrency, Wikipedia says it has its critics. It's true. Go makes concurrency, approachable. Goroutines, channels, it's elegant, it's powerful. But it ain't magic. You can still run into trouble, like data races, if you're not careful.
Data races sounds messy. What are we talking about here?
Imagine you've got multiple threads, those goroutines, all trying to access and change the same data at the same time. That's a data race, and it can lead to all sorts of unpredictable weirdness.
Okay, so even with Go's safety features, you still got to pay attention.
Always. It's like, yeah, you've got a car with all the airbags and lane assist, but you're still driving. Go gives you the tools, but understanding how to use them safely, that's on you, the developer.
Right. Great power, great responsibility. And speaking of responsibility, effective Go goes into how Go handles memory, specifically these functions, new and make. What's the deal there? They both seem to be about, like, creating things. Are they just two ways to do the same thing?
Well, they're both involved in memory allocation, sure, but they each have their own job. See, new allocates the memory you need for a new value of some type, but it doesn't put anything in that memory. It just sets aside the space and sets it to its zero value.
So, like, you get a brand new empty container.
Exactly. Now, make, that's more specific. You use make when you're creating slices, maps, and channels, these data structures we were talking about.
Ah, right, right. So what makes make different then?
Make not only gives you that memory, but also sets it up properly, initializes it so the data structure is ready to use right away, because those structures often involve like more complex setup behind the scenes.
So make is like, it not only hands you the keys, but also makes sure the fridge is stocked. Very thoughtful.
Precisely. All the setup is done for you. You just start using it.
I like it. Now, we got to talk more about how Go handles errors. Yeah. Effective Go, they really emphasize this. What's the philosophy there?
Go is very direct when it comes to errors. Like, you deal with them head on, no hiding. It can be a little more code compared to some languages, but it makes things so much clearer.
No sweeping things under the rug. I'm picking up what you're putting down.
Exactly. You're forced to think, what could go wrong and what do I do about it? And remember those multiple return values we talked about? Big part of how Go does errors right there.
Right, right. You get your result or you get an error, no surprises. But Effective Go also mentions these panic situations. Those sound a bit more, well, drastic.
Yeah, panic is like Go's way of saying, okay, everything's on fire, we can't go on like this. Not your average, oops, file not found error, more like the system's melting down kind of thing.
So, hitting the big red button.
Pretty much. Important thing is panic. Usually that means your program's done, but Go being Go, there's a way to maybe recover. This function called, wait for it, recover.
Recover. So you're saying there's a chance to get things back on track even after a panic.
It's like a last-ditch safety net. You can use defer, remember. Set up a function that runs if there's a panic. Log the error, clean things up, maybe even try to shut down gracefully.
Okay, now panic is sounding slightly less terrifying. Good to have a backup plan. Switching gears a bit, Effective Go talks about how Go extends the way types work. Something about embedding, not the usual inheritance thing, right?
You're right. Embedding in Go, it's super cool. You basically get to borrow the behavior of another type without getting into this whole complicated inheritance hierarchy.
So more of a mix and match approach.
You got it. Let's say you have a struct, and you want it to have all the same methods as, an IO reader. Handles reading data. Instead of inheriting from IO reader, you just embed it right into your struct. Boom. All those methods, now they belong to your struct too.
Like giving your type superpowers. And the book even talks about how this can lead to some really elegant code with interfaces like IO reader and IO writer.
Oh, for sure. You embed those interfaces. Suddenly your type can read and write data. No problem. Very versatile.
Very cool. Okay, let's get back to this whole concurrency thing. Seems like it's really at the heart of Go's design.
You could say that. Go was built for concurrency. From the ground up, it's all about doing multiple things at once, smoothly and efficiently.
And this is where our friends, the goroutines and channels, come in.
You know it. Think of goroutines like lightweight threads. You can spin up thousands of them. It's not even a sweat for Go. But the magic, the real magic, is how they talk to each other. And that's where channels come in.
Right, those communication highways we mentioned. So how does this all actually work in practice?
Imagine you're building a data processing pipeline, right? You could have one goroutine feeding data into a channel. Another goroutine pulls that data out, processes it, sends the results down another channel, and so on. Like a well-oiled machine.
And those channels, they make sure everything's in sync, no data collisions or anything like that.
Exactly. Share by communicating, that's the Go way. It's what makes concurrent programming in Go feel so elegant, so manageable. Not like those other languages, with their locks and mutexes, always fighting over data.
Night and day, huh? So, we've talked about how Go is elegant, how it has this whole philosophy. Does that mean there's like a Go code of conduct? Are there rules?
No, you better believe it. Go is very particular about how you write your code. Effective Go has a whole section on this. Following the conventions, it's a big deal.
So there's a right way and a wrong way to do things in Goland.
Pretty much. We're talking naming conventions, how you indent your code, even your comments have to be just so.
Wow. Okay, so consistency is key here.
100%. Go's all about readable, maintainable code. And having everyone on the same page, style-wise, makes a huge difference. Effective Go actually has some great examples of this in action.
Makes sense, yeah. Like, I'd much rather search for a book in a well-organized library than some dusty old bookstore where nothing's where it should be.
Exactly. And to help you keep things tidy, Go even comes with this tool, Go Fetch. It automatically formats your code to match all those conventions.
Like a spell checker, but for code, I can get behind that.
Right. Might seem strict at first, but trust me, this focus on consistency, it's a big reason why Go is so nice to work with. You spend less time deciphering someone else's code and more time actually, understanding it.
Gotcha. So Go has strong opinions on how you write code, but what about how you organize it? Wikipedia mentioned Go's package system is kind of unique.
Yeah, it's all about simplicity and scaling up. Each package has a path, like its address in your file system, and then there's its name, how you actually use it in your code.
Okay, sounds pretty standard so far. What's the twist?
So Go has this convention that helps you avoid those situations where two packages have the same name. Happens all the time in big projects. It's a mess.
Yeah, name collisions. Those are no fun.
The worst. Imagine two teams both create a package, same name, chaos. But Go's solution is pretty clever. They encourage you to use your source repository, like your GitHub account, as part of the package path.
So if I have a package, let's say it's called Amazing Tools, and it's on my GitHub, the path would be like github.com, your username, Amazing Tools, something like that.
You got it. That way, even if someone else names their package Amazing Tools, it's super unlikely they'll have the exact same path as you.
Like giving each package its own unique ID. Love it.
And the best part, this system, plus all of Go's built-in tools for managing packages, makes using external code a breeze.
Speaking of tools, what else does Go have up its sleeve? Effective Go mentioned a few, but I'm sure there's more.
Oh, yeah, Go comes loaded. We talked about GoFat, right, for formatting. But there's also Go Build to compile your code.
Oh.
Go Test for running tests. Go Get for grabbing external packages. Go Vet does static analysis. They've really thought of everything.
Like a Swiss Army knife for developers, very handy.
And that's not even mentioning the huge ecosystem of third-party tools out there. Go makes it easy to be productive.
Well, there you have it. We've covered a lot of ground here, from Go's origins to its quirks and unique features. I gotta say, I'm impressed.
It's been fun. Go really does offer a fresh take on programming. Simple, powerful, and elegant. What's not to love?
Definitely makes you think about things differently. One last thought for our listeners before we wrap up. When you're exploring Go, don't just focus on the how. Think about the why, the philosophy behind it. You might be surprised at what you discover.
Happy coding, everyone.